All right, hello everyone. I think we're going to go ahead and get started now. Welcome to the FiRa Consortium Public Transport Outreach webinar. We're thrilled that you're joining us today, and we can't wait to share more about UWB Basics, the public transport fare collection, and other FiRa use cases and FiRa member benefits. As a note, today's webinar is being recorded. At the end of the presentation, we will have a question and answer session, so please submit any questions that you have through that chat feature, and then we'll go ahead and address those at the time. And today's presentation will be led by FiRa Requirements Working Group co-chairs Frank Dawidowski from Sony and Srivasa Masi Parthasarathi from NXP Semiconductors. Frank is a standardization manager at Sony Europe Ltd, located in Stuttgart, Germany. Frank has been active in the FiRa Consortium since 2019 and is currently co-chairing the Requirements Working Group and serves as a member of the FiRa Board of Directors. He has more than 20 years of experience in standardization and has been an active contributor in a number of standardization organizations and industry associations. Srivasa is a technical director at NXP Semiconductors based in Bangalore, India. He has been actively involved with FiRa Consortium since 2019 as well, where he currently serves as co-chair of the Requirements Working Group and as a member of the FiRa Board of Directors also. With over 20 years of experience in software development and standardization, Srivasa holds 13 plus patents in the field of ultra-wideband technology. So with that said, I will go ahead and turn it over to our first speaker, Frank, to go ahead and get the presentation started.
Thanks, John. Next slide, please. So what we will be talking about today is the use of ultra-wideband for fare collection. So the key features of ultra-wideband fare collection systems, so what we can do to implement ultra-wideband for fare collection is the coexistence with existing legacy fare collection solutions like NFC-based solutions, for example, uninterrupted passenger flow during rush hours, the accessibility-friendly hands-free entry so that you don't have to touch a card or even insert a ticket, for example, the capabilities of dynamically switching inbound and outbound gates so that you can use the entry for both entry and exit. In general, fast and efficient transactions, and also the privacy-preserving nature of some of the ultra-wideband modes. Also, just to point out, as you might know, ultra-wideband is already deployed today in many smartphones. Go to the next slide, please. So the agenda for today's webinar is that we will first cover a bit about FiRa, then talk about basics of the ultra-wideband technologies. Then I'll hand over to Srivasa to talk about the public transport fare collection use case in a bit more detail. We will cover a few additional FiRa use cases that are applicable to transport systems, train systems, and similar environments. And then finally, we will talk a bit about FiRa member benefits and, as John already mentioned, have a Q&A session at the end. Next slide, please. So the FiRa consortium, so FiRa stands for fine ranging, and it's all about precise localization, precise location awareness, and measuring distances and angles using ultra-wideband technologies between objects. So that's what FiRa is all about. Again, FiRa stands for fine ranging. Next slide, please. The consortium was founded in 2019 to make ultra-wideband-based fine ranging a reality. And FiRa is set up as in several working groups. So we are working on use case requirements, specification development, Also on the testing side, so we have a compliance and certification program. We are doing market education and public outreach, and have strong industry collaboration. So we are talking with other organizations that are active in the field and are collaborating with them. FiRa itself is a US-based non-profit organization, and we are committed to collaborating with other consortia to develop the ultra-wideband ecosystem. Next slide, please. Just having a quick look at our members and the ecosystem. So as you can see, the sponsor level, so the board of directors already is has several of the large companies as members covering different areas. So we have device vendors, we have semiconductor companies, solution providers, and so on. And then looking at our wider membership, we cover a lot of the different fields that are necessary to bring a technology to the market. So we have service providers, system integrators, also tool developers and test labs, and so on. So pretty wide coverage that should enable us to roll out ultra-wideband into the market. Next slide, please. The structure of the working groups is, you can see that on the screen right now. We have groups that are working on technical specifications on the certification side, marketing, regulatory, and security. And also the requirements working group, which is hosting this webinar. So requirements working group is all about market requirements for the different use cases and defining what the specifications need to be able to accomplish in order to be successful in the market. In addition, we have a working group steering committee that is focusing on the coordination between the different groups. Next slide, please. Now, having a quick look at ultra-wideband technology. So ultra-wideband is an impulse radio using very low output power and a very high bandwidth. So it's about 500 megahertz bandwidth. And due to these very short pulses, the technology is very good at precise and secure positioning. The underlying technology is specified by IEEE. So the standard is 802.15.4. And FiRa is building on this IEEE specification and creating profiles and a test program around that and making it usable for various use cases. Next slide, please. So if we look at the advantages of ultra-wideband technology, it's very secure. So it has already on the PHY level methods of making it more robust and more secure than other technologies. It's very real time, so it has a high refresh rate. Can coexist with other technologies. First, because it's typically in a different band, but also because of this very broadband nature of the technology. It's pretty reliable. It's immune to multipath and interference and fading, and we can achieve down to centimeter resolution even in dense multipath environments. Also, due to the ultra short pulse width, there's a pretty low energy requirement on the sender side. Next slide, please. Quick look at the protocol stack. So as mentioned before, we are So the FiRa specifications are based on the IEEE specifications. We are profiling the features that are defined by 15.4 and add test methods and so on. And then we have on the higher layers, we are specifying framework and profile specifications that are then defining the higher layers and making the lower layers accessible for the service. So again, it's based on IEEE and then adding on top to define an interoperable framework for using the technology. Next slide, please. Now a quick look at how ultra-wideband ranging works. So we have different ranging modes. One is the two-way ranging, where two devices are measuring the distance between each other, and there we have an initiator role and a responder role, as you can see in the picture in the middle. So in this case, two devices are involved and using time-of-flight measurement to actually measure the distance. Then there's a different mode of operations that we are calling one-way ranging, and there are two variants of that. So we have the one-way uplink ranging, where we have a fixed anchor structure that is receiving signals from a moving device for ultra-wideband tag. So typically uplink ranging, for example, is used for asset tracking use cases. Then there's the reverse case where we have a fixed infrastructure that receives that sends signals to a moving device. So in that case, for example, you have a number of anchors in a large venue, and the mobile device receiving these signals can use these signals to position itself. So it's a kind of indoor GPS, and it can be used for precise location finding within indoor environments. And we call the uplink version uplink TDOA typically, and the downlink version is downlink TDOA. Next slide, please. There's more information on the different use cases and FiRa technology on our website. So we have a number of short videos there, so you can find that directly under resources on the FiRa website. Just in case you want to learn a bit more about FiRa. And then if you go to the next slide, Jordan. I'll hand over to Srivatsa for the public transport section of this webinar.
Thank you, Frank, and good morning, all. Welcome to this webinar again. So now I'm going to go through some of the things about the transport fare collection, and Frank explained the reasons and the motivations around it. Just to walk through some of the important aspect of it, right? So why it was so important from FiRa perspective for the group of companies, the member companies who thought this as one of the important use case to work on. Right. So first thing is the touchless aspect of it. So which brings a lot of convenience to the user. It's basically simply walk through the gates carrying UWB enabled mobile device or any wearable, right, in an activated public transport fare collection service. So the overall user experience that one expecting out of this is pretty seamless, and that brings a lot of value in terms of how in day-to-day life this will be used. Another motivation to make it is more interoperable, right? Interoperability in many aspects is about how in the ecosystem all these devices who are from different OEMs or different vendors are collectively working together. That makes a true interoperable ecosystem. How FiRa is enabling such interoperability is through the certification program. where FiRa offers core certification of these devices, where any implementation of the core features that are done, they go and evaluate themselves with the certified test tools and the test lab, which really ensures that any of these devices which are coming into the market, coming into the field, are interoperable and makes this use case truly end-to-end working. And that's very, very important goal in that aspect where FiRa was looking at this use case and is continuing to look into different aspects to make it interoperable there. The next aspect comes in backward compatibility. So when we talk about touchless, more user experience, interoperability, also important aspect is to look at the backward compatible aspect of it. So which means that the existing touchless payment methods that are there like NFC, which are already there in the infrastructure, should continue to coexist along with UWB. That is the aspect in which this thought process is done. And fundamentally, another important aspect for other transport operator is how easy to deploy. Um, if you look at the use case and how this will be used, UWB is just another radio along with it. So you have contactless payments with NFC, and then UWB is added on top of that, which ensures that it is easy to roll out. The no backend infrastructure is modified, and targeting a limited number of gates and station is all supported when it is rolled out in phases. So the reason is that once a new technology is introduced, first anybody wants to understand how this is working and how this is getting used. One of the important aspect of any of these such use cases is also about users themselves getting used to how it is working. They also need to go through self-learning process. So when you roll out these in phases, um, it should be easy for these transport operators to deploy and then scale up accordingly. Next slide, please, Jordan. So the groundwork of this particular use case and where we are going, it started in 2023, where a group of companies in FiRa got together and took a lead in terms of defining how this use case should look like, because there were multiple aspects to bring in, to think about. Uh, it's a new radio. With all the aspect that I talked about in the previous slide, how these needs to be brought together, and that is where the collaboration happened in the FiRa consortium, um, and out of that, a white paper was published in FiRa. So this particular white paper talks about important aspect, design aspect, and some of the technical viewpoint, how these problems can be solved in this. So the link is over here, and this is very much available in public, and some of you might have gone through it, but definitely we both encourage for the audience over here to go through whenever you get a chance. Next slide, please, Jordan. So when this white paper was drawn, so the important aspect that everybody was thinking about is the performance. How you are able to experience a throughput performance in typical crowded scenarios. And what we all thought and decided was that the best way to achieve this kind of performance and seamless user experience to have 60 people for 60 seconds per gate through the axis, which roughly translates to 1 person per gate, right? So you are able to per second, you are able to access through the gate. So this was seen as an industry standard to achieve any kind of fast throughput and allow the user to experience this transition from how they were doing with contactless payment versus using UWB as a methodology. So there are aspects what UWB brings in is that with respect to proximity estimation that are happening, um, a gate as such will be able to locate the user at a farther distance compared to other technologies, which brings its own set of challenges to address. And these challenges are part of the technical study, technical development that have gone through and standardized in FiRa today. Next, please. So what you see the content over here is something that you will see in the white paper as well. Just to give an introduction in terms of what you see in the user timeline in the transit station. A user is entering, and you may just see how in an ideal situation that happens is that typically user will be seeing their mobile, at their email or having watching video or anything, and they should be able to pass through the transit gates, which allows the fair transaction to happen. So there are multiple phases that gets involved in this whole process flow of the system. And what we would like to do is to just introduce to in each of these phases how the user would experience certain things. Next slide, please. So phase one, what we call is the discovery phase. This happens during the entry of the station. You might be thinking why we are talking about Bluetooth low energy beacon as a way to signal for a wake up. And the question could be that, is this the only way to wake up? For now, when we thought about these things and group of companies and the member companies, when they thought there should be a need of interoperability, which we emphasized in the beginning. And the true interoperability happens when we think about one solution to ensure that it is seamlessly working all along and easy to deploy as well. And in that aspect, the thought process was to bring Bluetooth Low Energy as a wake-up device. There are other methods possible as well, but in terms of these aspect, that is interoperability and easy to deploy, Bluetooth Low Energy is considered as a discovery scenario. So when the user enters into the station area, the user mobile device should be able to discover this particular BLE beacon, and that enables configuration to happen on the mobile device for that particular transport operator station. So this could involve all kind of profile configuration, etc. information that comes out of this particular BLE beacon advertisement. Next slide, please. Here in phase two, we identify something as untracked navigation. Untracked navigation is nothing but downlink TDOA, which is kind of one of the variant of one-way ranging what FiRa has standardized. So this is an optional step that is present. And what you see is that when the user gets to the discovery, and when the user is walking towards the gate, um, it's up to the user also to understand and decide when it has to participate in the ranging with the transit gate, and that gets enabled when the user is able to locate themselves and navigate themselves towards the gate. So it is in a way where it enables the user mobile device to understand the look the locality in which they are there, and also enables themselves to start participating in the ranging. So from phase one discovery to phase two, and where we say this as an optional phase to go through, because on-track navigation is very important, but at the same time it has its own set of configuration and deployment constraint that also gets added for a particular transport operator. Um, this is a transition phase from going from phase one to phase three. Next slide, please. So what you see is the discovery and the selection and the FiRa transaction that you're seeing that is happening. This is something what we call as phase 3. Here in this particular phase, the gate is discovering the user devices. That means they are doing fine ranging with these devices, and maybe secure ranging also along with it, how this particular use case gets deployed. Thereafter, once the gate is able to locate the users, it performs the FiRa transaction after that. So the important aspect to know is that the user device starts communicating with the gate infrastructure in this particular phase. And the gate infrastructure locates the closest user who is walking towards the gate, which means that the gate is somehow localizing these particular users who are closer, and then selects the particular user for FiRa transaction. And interesting to know is that all these things are happening within the UWB transport layer itself. So all our in-band transactions that are happening, the anything to do with discovery, selection of the device, FiRa transaction, all these are happening in band, which enables for the system to provide these kind of seamless experience, mainly the convenience and probably the better user experience compared to other technologies. Next slide, please. So once we have gone through these things, so just to recap on the key features of UWB for FiRa collection system, right? So it's the coexistence with the legacy FiRa collection solutions. Historically, there have been a lot of deployments that are there and proven systems that are already working. So what UWB does is it adds another radio on top of it so that it works along with other existing FiRa collection system. Uninterrupted passenger flow even during rush hours, right? This is one of the key things when multiple companies that are there in this contribution collaboration in FiRa who thought that probably this gives a better user experience especially when there is rush hours, and accessibility friendly, right? So a lot of people with different kind of disabilities and other things, for them it provides a very convenient hands-free experience. It also gives dynamic switching from inbound outbound gates. It also allows for different configuration of the entry exit gates, etc. Right. So these configurations can be possible in a station, and all these are possible with this particular technology. Allows for fast and efficient transaction. Right? So fast in the sense that the UWB as such provides higher data rate, which then allows for faster data transaction, etc. So which allows again the fast transaction experience, and also privacy preserving. So UWB as such is one of the proven technologies in terms of providing secure ranging, secure way of communication. So and also provides better privacy for the user. So these aspects overall makes UWB as a very good choice for this particular use case. And what good to know is that there are a lot of devices which are shipped today in the field. They already have UWB, and these technologies already available in the smartphone. So once this technology evolution happens, all those devices which are there in the field will automatically get the enablement to this particular use case. Next slide. Frank, I'll hand over this to you
Yeah.
now.
Thanks, Shweta. So a quick look at what's happening in the industry right now. So we have already seen press releases and similar information about the first deployment of ultra-wideband public transport ticketing by Shenzhen Tong, sorry, in China. So this shows that the technology is actually already deployed in the market to obviously to a limited extent right now. but there is certainly a strong interest in ultra-wideband for public transport ticketing, and is showing evidence that this can actually work in the market. We also have seen several proof of concepts. So, for example, the one completed in Seoul some time ago. We have seen public announcements of the intention to deploy touchless gates, or how they call it, walk-through gates, by Japan Rail East, with a very bold timeline, and how they want to roll out these walk-through gates throughout their network. And as mentioned several times already in this webinar, there are already a number of ultra-wideband enabled mobile phones in the market, and they are becoming more widely available. There's a running list on Wikipedia, for example, where you can check which models are supporting ultra-wideband. So FiRa as an organization is very involved in this use case. So we are talking with a lot of important stakeholders, and are really planning to move the industry forward in this, and we are inviting all the other industry leaders to actively participate in this effort, so that the deployment and the specifications that FiRa is working on, as well as the certification program, is matching what is required by the market. Next slide, please. Now a quick look at a few additional use cases. So as you can see on this slide and on our public website, ultra-wideband ranging technology can be applied to many different scenarios, and can bring convenience to these different use cases. So we have, for example, untracked navigation was already mentioned several times, which is a great method for indoor localization. We have access control use cases. Ultra-wideband can be used for payment, and many different things. So we are categorizing these different use cases into different areas, like smart home and consumer, smart retail, smart building and industrial, as well as smart cities and mobility. So ultra-wideband covers a broad range of different uses. If you go to the next slide, I would like to focus on a few of them that are in particularly applicable to transport networks and large train stations. So as mentioned, untracked navigation is a great way for indoor localization, for indoor positioning, and this kind of indoor GPS, as mentioned earlier. Then we have the asset tracking use case to help operators to keep track of their moving assets. So this is also a very interesting use case where ultra-wideband can be used. In addition, of course, there in big stations, as we see, for example, in Asia and many other regions, there are lots of vending machines and maybe small shops and so on. So also for payments, for making touchless payments a reality, ultra-wideband can be used. And also not only for the purely gate-based transit stations that we are focusing right now in this webinar, is ultra-wideband a good technology, but also for other transport-related use cases, like ticketing validations, like bus tickets and so on. So there the environment and the details are a bit different, but ultra-wideband itself as a ranging technology, and with the capability for secure ranging, and with a direct connection to the secure element, for example, is a good technology choice. Next slide, please. So yes, with the currently published FiRa 3.0 core specifications, all the core features that are required for this use case are already specified. And just to go through these features quickly, so we have contention-based ranging, meaning that devices that are unknown to each other can announce themselves and can set up a ranging session. So therefore, in contention-based ranging, one device is sending out ranging messages, and then a device that is not known before can join in these contention access periods. In addition, hybrid scheduling is a very relevant feature. So hybrid scheduling enables the devices to split the ranging set or manage the ranging session in a way that several ranging methods can be used at different predefined times, so that you can have a contention period, and then you have dedicated ranging and data access period, and so on. In addition, the dedicated data transfer enables us to use ultra-wideband in-band for data transfer. So, for example, for the payment transaction. So also very important feature. And then, in addition, a secure ranging, so making sure that the distance that you're measuring is actually the right one and that it cannot be easily intercepted. So all these features are already part of the existing core specification release. These specifications are free for members, for FiRa members to download, but they're also available to non-members for purchase at the link shown below. In addition, so FiRa is not only specifying what we call the core, so that's the part for the so MAC-PHY and the interface to the host, so the UCI level, but also is working on the higher level specifications that we call framework and profile. So the development here for the first release is ongoing. Next slide, please. Yes, so quick look. So obviously we are doing these webinars also to raise interest in becoming a member of the FiRa consortium, to actively collaborate and work together with us to make this use case a reality. If you are becoming a member from associate level and up, you can directly join the various working groups and actively contribute. But also the adopter member level that is more affordable allows you to access the specifications for free and to get your product certified. So if you have interest in joining FiRa, please reach out. There's information on the website. Should be pretty straightforward, and we are always welcoming new members and are excited to work with you together. Next slide, please. Yes, so here a list of email addresses. The easiest one is just to reach out to our admin team if you have any questions about membership or really anything else. And then you can also contact directly our board of directors, so our chair of the board, SK Young, vice chair, and our treasurer. And I believe that brings us to the Q&A session. Yes, so please, if you have any questions, send them in the chat. And Jordan, do we have already some questions from the audience?
Yes, we do. We have a queue waiting to be answered. Would you like me to read the first one out?
Yes, please.
Yeah. So from Vimal Shankar, does UWB support remote wake up?
Shweta, do you want to take this?
Yeah, so FiRa is based on 802.15.4z 5. So what we talked about FiRa 3.0, and FiRa does not define any wake up feature, remote wake up feature.
Yes, maybe to add to that, so that's why we are using typically, for example, Bluetooth beacons as a wake-up radio, so that the ultra-wideband chip is only activated if there's actually an ultra-wideband application or ultra-wideband use case happening. Jordan, could you go to the next slide? Sorry, next question.
Yep, so submitted from Andy. Do you have a proposal for onboard validation as well, e.g. bus, light rail, etc.?
Yes, a good question. So the ticket validation use case is certainly on our list. Right now, we are focusing on the gate-based use case because this is the one where we see the most interest, and it's also the most complex to solve. But certainly, ultra-wideband and FiRa technology can be used for ticket validation and similar use cases. So if you have any more specific questions about this, also please feel free to reach out.
And the next one we have is from Emmanuel Ferro. Are you already working with contactless ticketing associations, example, Calypso, and ticketing system integrators / ticketing solution providers?
So thanks for the question, also a good one. So we are just about starting our kind of public transport outreach activities right now. We have had discussions with big public transport companies that are using NFC and the contactless ticketing right now. And we will continue that outreach. So Calypso is certainly one of those organizations that we are planning to work with. And also, of course, system integrators and solution providers are an important part of the value chain for public transport fare collection. And we are very interested in collaborating and working together with those companies.
The next one is a multi-part question. So from Thomas, a significant part of smartphones with UWB are iPhones. As far as I know, Apple does not support UWB communication when the app is not active. Do you have a scenario for active usage of UWB in public transport rather than passive hands-free option you described? Does Apple support FiRa?
Yes, so Apple is one of the sponsor companies of FiRa, of the FiRa consortium, is part of the board of directors. So certainly Apple is very active inside FiRa. So that's, I think, I can say. Other than that, obviously, there are choices. So companies have to do their own choices and have to decide when and how to implement different things. As to the specific question, as mentioned, so public transport fare collection and in general the FiRa 3.0 use cases are pretty new. So I think some of this is simply a matter of timing. I know, Srivatsa, do you want to add anything to that question?
I think so. That's pretty much you answered over there. Because one of the thing what is mentioned is passive hands-free option that you described. I don't think so. We really talked about passive hands-free. We talked about seamless user experience. But again, as Frank mentioned, how this gets implemented on a particular smartphone is probably not in the scope of discussion that's there in FiRa. So the implementation choice varies from OEMs to OEMs.
If nothing else to add there, I'll move on to the next question. So submitted by Cindy, what's the solution of coex between FiRa and Omlox?
I don't know if I entirely understand the question, but so FiRa has a liaison with Omlox and is in active discussion with the Omlox community on coexistence between both these specifications of both organizations. I think the focus is there mostly on asset tracking use case. But yes, there are ongoing activities and ongoing discussions between both consortia.
Great, thank you. And it looks like the last question that we have at this point submitted by Thomas is, what is the status of UWB payment methods? Are there any cases in an advanced stage of development?
So for ultra-wideband based payment, basically the same features are needed. So the Core 3.0 release already provides the functionality and the features that would enable ultra-wideband payment. We see significant interest in the use case, in the ultra-wideband payment use case, and are in active discussions with, for example, with EMVCo. We also have members from the payment industry like JCB. So in our membership, we have expertise in payment, and we have seen several demonstrations around the payment use case, exploring how payment can be implemented using ultra-wideband technology. It's a complex use case because there are so many variants and so many scenarios where payment is, so how payment is conducted. So I would say it's still, the industry is kind of exploring how to do payment using ultra-wideband, but certainly there's a lot of activity going on, and payment and the payment use case itself, of course, is a very high-profile use case for FiRa and for the ultra-wideband industry.
Yeah. So just to add a few things to it, so the public transport fare collection has very similar problems that to be solved for payment use case as well. So one of the baseline to draw there is that certain problems, certain scenarios that is solved in public transport can be leveraged to payment as well. So as Frank mentioned, there was considerable interest even in FiRa's last members meeting. There were member companies who were showcasing their demos. Thanks.
Thanks. John, are there any further questions?
That was the last one that we have, so.
Any further questions from the audience?
Don't see any others coming through.
Yeah, seems not to be the case. Then I'll hand over to you, Jordan, for the closing.
Perfect. Thank you, Frank and Srivasa, and thank you everyone for joining us today. You'll see on the screen there's a QR code. If you don't mind scanning that and take a moment to complete the survey, help us get better for next time. Then we'll also send out a post-event email with the link to this survey. So please take a moment to do that if you have the time. And otherwise, thanks so much for joining us today.
Thank you.
Thank you all.
Thank you. Bye.